All right, so in this problem here, we are trying to graph this higher degree polynomial. Now, luckily for us, the polynomial has been given to us in factored form, so determining all the intercepts will be a lot easier, right? Whenever you're trying to sketch the graph of a polynomial, we want to first be able to identify the x-intercepts, right? So let's solve for those. Now, if you guys remember, x-intercepts are when the function is along the x-axis. If I have a coordinate on the x-axis, then its y value, right? If I have some coordinate on the x-axis, its y value would be 0, right? So x-intercepts are basically just any x values where the function is equal to 0. And that's going to be whenever each of these factors is equal to 0 itself. So when x is equal to 2, then 2 minus 2 would be 0. And as soon as one factor is 0, right, everything's 0, because 0 times anything is equal to 0. So because of this x minus 2, I have an x-intercept at 2. Because of x plus 3, I'll have an x-intercept at negative 3. Because of the x, I'll have an x-intercept at 0, actually, right? Because when x is 0, I have 0 here, multiplying everything to make 0 overall. So those are my x-intercepts, right? So it's at negative 3. We'll call this point here negative 3. At 2, and at 0, right? Now, after you find your x-intercept, you're going to want to find the y-intercept. Uh, Now, your y-intercept is when your function is a point where you're on the y-axis. And you'll see here, when I'm on the y-axis, my x-coordinate should be 0. So no matter what your function is, to find a y-intercept, we just plug 0 in for x. So if I plug 0 in for x here, I will actually end up getting 0 because of that x-intercept of 0, right? Think about it, guys. Negative 0.5 times 0 minus 2 cubed times 0 plus 3 times 0 squared. Here, let's write that out. Negative 0.5 times 0 minus 2 cubed times 0 plus 3 times 0 squared. Check it out. What's the y-intercept? It's going to be 0 because 0 is being squared. That's equal to 0. And 0 times all this other stuff is going to still be 0. Cool. So we have our intercepts. Once you've plotted your intercepts of a polynomial, we just need two more things. We need to, first of all, figure out, in this case, right, in this problem, we're going to need to figure out some point in between two of our intercepts. We basically just, all we're trying to solve for is it positive or is it negative between these two intercepts? Now, the reason why I want to know that is because typically your y-intercept could help guide the overall shape of the function, right? Like where your line is. But when the y-intercept is 0, that becomes a little bit less useful. So all we need to do is figure out when I'm somewhere in between these two zeros, am I above or below the x-axis? So how can we do that? We can just plug the number in. Here's negative 1. Let's plug negative 1 in. So if I plug in negative 1, I have negative 0.5 times negative 1 minus 2 is negative 3 cubed. Negative 1 plus 3 is 2. And negative 1 squared. Now, is that going to be a positive or a negative number? One of the great things with this is that you actually don't even need to evaluate this. You could just think about it, right? Negative squared is going to be positive. 2 is positive. Negative 3 cubed will be negative. And negative 0.5 is negative. So what does that make? Two negatives make a positive. So I know that at negative 1, my function will be above the y-axis. Okay? And since I'm just sketching it, I don't really need to know too deeply about where that point is. We could calculate this. It's not too hard. But for now, let's just leave it up there. The final thing we need to recognize, guys, is the multiplicity of these zeros. Remember, the multiplicity is the exponents. So the 3, this guy's a 1, this guy's a 2, right? Yeah, let's take that back. It's kind of blocking our view. So the multiplicity of the x-intercepts is just based upon the exponent on the factor. So see how my x minus 2 is to the power 3, so the multiplicity of that 0 would be 3. X plus 3 is to the power 1, so it has multiplicity 1. X is squared, so it has multiplicity 2, right? So what that multiplicity does is it affects how the line actually cuts through the x-axis, remember? Um, so, oh, I lost our point up here earlier. So let's go ahead and start with this point up here. The reason why we created this point was so that we could kind of have some starting point to guide us as we go through. So I'm coming here. If I went to the right, I have only one place to go. It's to that intercept, right? But what's the multiplicity of this intercept? 2. When I have an even multiplicity, what's going to happen is it's going to go touch the intercept and bounce off the x-axis. Remember that, guys. Even multiplicity means that it bounces. Okay, we keep going. It needs to, at some point, it goes up, right, because of the bounce, but it's going to come back down. And we go to this intercept at 2. The multiplicity of this intercept is 3. Now, if your multiplicity is odd, the function is going to cut through the line. See how I cut through the line? Because it's odd. Just like how over here, let's look at to the left side. It's going up, it's going to come down at some point, and our intercept at -3 is multiplicity 1. That's odd, so it should cut through. And here's our sketch of the function. One thing to take note of here, guys, notice how I've cut through my intercept at -3. It's very straight. Whereas the intercept here at 2, I kind of flattened the curve, right? See how the curve steadied for a little bit there and then kept going? This is due to a higher multiplicity, right? If the multiplicity is 1, it cuts through straight, kind of like looking like the y equals x function, right? Y equals x is just a straight line. Whereas when it's a multiplicity 3, it actually is going to kind of do a little bit of a flattening on the curve, kind of like y equals x cubed it looks, right? Y equals x cubed does the flattening. So that's kind of like a little bit of the insight of why is my line flattening here, whereas it's straight here. This also explains why it bounces off the x-axis when it has an even power, right? Y equals x squared, that function is just a parabola. You can see it bouncing. So this is our final sketch of the graph.